So this week we're gonna be thinking of operations with decimals, which is similar to fractions because both are used to express like parts of a number. And we're also gonna explore some cool stuff, intriguing stuff you could do with it, such as number lines and how it connects with fractions. Actually, before we will start, I'll go over a public service announcement, which is abbreviated as a PSA. We actually have decided to have the hours you fill out a form for the office hours if you need help with anything or want to question. So you fill out this form and then we'll schedule a meeting with you through email. Usually over the summer we're free generally during the afternoons on weekdays. But if not, you could also always feel free to suggest other times you're available. And we could also do those too when we don't have anything. And by the way, another logistical concern was last week. It seems there was trouble with accessing the form. So can some of you tell me were you able to fill it out before granting access?
Yeah.
Okay. So I think that I may be wrong, but I initially thought that as long as I posted the form, you could do it. I don't have to give add edit access because that's for filling in and making the questions. But I'm not sure. So, but all of you girls who want to do the homework, were you able to fill out the forms for the pre-assessment and homework?
Yeah.
Okay. Were you like Olivia, were you able to do that before I granted you access, or did you first have to request?
I think I did it yesterday.
Okay. Then I guess we'll try it again this week. And we may discuss this at the end of class. But now we're gonna go.
Can I mention something really quickly?
I'm sure.
So if the Google form doesn't work, you can just upload a picture of your answers, or you can have a Google Doc and put your answers in it, and then we'll check over it later. And also we posted the office hour Google form on Google Classroom, and if you can't access that, you can always email us. And I think we've told this to you guys already, but I want to put our emails in the chat. So if you have any question, you can just email us there. So yeah, Jennifer, you can continue.
All right, sure. So first, before we dive into the content, we'll think about base 10. So decimals are expressed in base 10, where each digit of numbers lined up tens, hundreds, thousands. They are going forward tens, hundreds, thousands places. And each are basically units of 1, but times by a factor of 10. Times the powers of 10. And for decimals, it's basically the opposite. Instead of timesing by factors of 10, you divide by them. And numbers are usually expressed in decimal form, but there could also be other bases, such as base 2, which you sometimes see in computers, like then 1, 1 will be 2 plus 1 equals 3, for example. All right. So let's dive into some review. Probably some of you girls already have heard of decimals. Well, a decimal is used to represent a portion of a whole. It contains 3 parts: an integer, which indicates the number of wholes, a decimal point, which separates the integer on the left from the decimal on the right, and decimal number, which represents number between 0 and 1. For example, let's dissect such a number, decimal 3.14159. It's actually the first few digits. Why does this keep on going? So these are actually the first few digits of pi, and it's read as 314,159 hundred thousandths. And the dots read as and. That's just like reading and notation concern. So whole numbers can also be written with 1 or more zeros after the decimal point, such as the example shown with 3. And here is a visual representation of decimals on a number line. You could see the numbers here. It's by tenths. It's basically a number line with whole number marks scaled big by a factor of 10. The number lines could also be scaled by other factors, such as a factor of 2, where there is a tick mark at every whole number and every whole number in the half. Any rational number can be expressed as either a terminating decimal or a repeating decimal. And a rational number is a number that can be expressed as A over B, where A and B are both integers, which means they all are like whole numbers. And and it also could be negative too. Then a decimal such as 0.25, which stops, is called terminating decimal, since it doesn't go on with more digits. It's not like 0.25, 25, 25 forever. A rational number A over B in lowest terms. So in lowest terms basically means the greatest common factor of A and B is 1. So A over B is a simplified fraction. It results in terminating decimal if the only factor of the denominator is 2 or 5 or both, or it also could be neither, which means the denominator is 1, which means a whole number. If a fraction's denominator has only 2 and 5 as its factors, the fraction can become a terminating decimal. The length of the decimal part equals the greater power of 2 or 5. You could see this by, let's say, b equals 2 to the power of x times 5 to the power of y. And let's just say, one case x is greater than or equal to y, a over b is this thing. We substitute this for b. That then can be written as needs to be x times 5 over x, where you times 5 to the power of x on top and bottom, which equals well, we're given, you get this, that a and 5 to the power of x are integers, because a is an integer by default, and 5 to the power of, and then x over x minus y is, because x minus y is greater than or equal to 0 and it's a whole number, it's also an integer. So that means that it's basically, we could write this fraction as an integer a times 5 to the power of x minus y, and then we move the decimal place to the left, x times. That means that the length of the decimal is x digits. And similarly, if y is greater than or equal to x, then a over b can be rewritten as indicate this case, y minus x is greater than or equal to 0, and a and 2 to the power of y minus x are both integers. So then you could also similarly write the top part numerator as an integer and then move the decimal place to the left by x. And that means that proves the point that the length of the decimal part equals the greater power of 2 or 5, or equals both if they are equal. The explanation may have been a bit complicated and beyond and advanced for y'all, but I'm just like introducing it. And with powers too, if you haven't seen them yet, you'll explore them later, but I just want to introduce them to you if you guys wanted to explore.
Wait, I have a question.
Yeah.
So you said that, wait, so how did you get minus x or y on the top?
You mean y minus x?
Yeah.
Oh, so first we are given that y is greater than or equal to x, and then I'm not sure if like you are familiar with like basic algebra, or if you learned that in like pre-algebra or something. Then if you minus x on both sides, you can do that like with equalities or inequalities. That'll be true. So you do minus x and minus x.
Oh,
Okay,
thank you.
you're welcome. Now, for example, some fractions. Here, there's 1 over 5, which can be expressed as 0.2. 1 over 25 is 0.04. 1 over 125, this, and the last one, is expressed as this. These are actually all powers of 1 over 5. You could see like the decimal representations consist of powers of 2s, except the decimal point is moved. And that makes sense because 1 over 5 can also be written as 2 over 10, which then you could see it's basically when you times 1 over 5 to some power n, that's equal to 2 over 10 to some power of n, where it's basically 2 to the power of n over 10 to the power of n, so you just move the decimal point n times to the left. And there's some rules to convert decimals into fractions for common ones you may see. A rule is the fraction of any single digit repeating decimal is that digit over 9. And you could prove this by using long division. Let's just say the unit fraction 1 over 9. And then through long division, we'll get that it always remains a remainder of 1. Have to put a 1 here and then drop 0, and that's 10 again. So you have another 1, and another 9 down here, and it's going to continue on. This can be expressed as 0.1 be line. Line means that the 1 goes forever into like digits all the way the decimal to the right of the decimal place, like an infinite amount to infinity. That's actually a hard thing to wrap your mind around, but that's just the concept of math. So when you know it works for 1 over 9, then let's say a digit's d, which is some digit 1 to 8. All right, and then d over 8, d over 9 is equal to d times 1 over 1 times 9 equals d over 1 times 1 over 9, which equals d times, once we derive 0.1 with a 9 on it, and then it equals 0.d. You could see this if you use like just multiplication. We multiply it out, for example, like we have here, 0.5. So 5 over 9 equals 5 times 0.1 with a line on it equals 0.5, because it's 5 times this. It's 5, go on forever. And rule 2, the fraction of any 2-digit repeating decimal is the digits over 99. This is like it's a similar structure to the first rule. And you can also find that by long division. First, take the unit fraction 1 over 99. And once you do the long division, you'll also find a pattern here, because then you have 100 again, but you place 1 here. You get 99, which leaves a remainder of 1. Now, the first time you have 0, because 99 goes into 10 0 times. Then after that, drop another 0, goes into like 1 time, have 100 again, and go so on. So that's also a repeating decimal, which is indicated as this. Because then, like the first example, the digit 0, 1 goes on, like smaller digit places. And then let's call a number t, which is a whole number between 1 and 98. Or actually, let's call the number AB. It's not A times B, but it's like number AB, because it could be 2 digits, 1 to 98. And we want to know that AB over 99 is equal to 0.AB. We could see this by knowing that this is equal to times 99 equaling AB times 0.01, which then if we do multiplication, we'll get to this, what we want to find. And an example of that is 0.35. Who wants to tell me how you convert this number into a fractional form? So basically you go backwards.
I think 0.35 repeated, you first multiply by 100, so 0.35 equals x, and then 100x equals 35.35 repeated, and then you do 100x minus x, so that equals 99x equals 35, and then you do 35 divided by 99 to get x, so you get 35 over 99.
Yeah, that's correct. Yeah, I think the steps that you did are good. And what I was gonna say for this method was just to keep in mind to convert. You know that it resembles like a number AB over 99, which you could rewrite as this, since it's a repeating block of 2 from the tens digit. And you see that AB equals 35, so then that equals 35 over 99. And a similar thing, the next number is kind of a twist. Who wants to take a try at it and announce what they think?
Is the denominator going to be 9,999?
Yeah, that's correct. This is equal to this thing. And yeah, there's a pattern, like for repeated fractions like these after the decimal point, and there's like just how many digits repeating. That equals repeated number over for how many digits the repeating block is. Let's call it X. So it'll be a string of X9s on the bottom. You could get a sense of this using long division, trying out it for multiple, like lengths of repeating blocks or strings of 9s. And there's actually a beautiful proof of it involving geometric series that actually involves like advanced, very high math skill and math concepts, which you girls will probably discover like soon in your math pursuit. And now we're going to look at some problems. I'll let you girls try the first. Okay, I don't know. Do you girls want more time, or do you want me to just explain them and know it by explaining? Looks like one person private chatted to me. I'll also do a walkthrough to see how the answer turns out. What you want to do, you could separate the whole number part from the decimal parts. I got another answer. There are two different ones. So let's derive it together.
Wait, it's repeated?
Yeah, it's repeated. You may have not really recognized that yet. Yeah, when you, especially for this speed, like be sure to look out for whether it's repeated, indicated by the line on top.
But I don't see a line.
It's here to calculate 2 point. There's line above 4/8.
I only see a line above 4/8, but not a line above 8/3.
Yeah, there is not a line above 8/3, just above 4/8.
Oh.
Yeah. Yeah, I guess I accidentally put a line here. Then you have to find this part. Let's take care of that. Well, what you could do is just write out the first few digits of 4/8, although it's forever, ... You just align them with the terminating decimal 83. And you see, so the rest goes 0, 0, 0 all the way. That means that some after from thousands digits forward, it's almost the same as this number here, 448. And then you use like digit addition starting from the 100th place. You get this part is equal to this. And if you add them together, it's 4 plus 1.31. And 4 dot dot 484 dot dot dot, which can be indicated by a line on top of just the 4 and 8, since 3, 1 doesn't repeat. Which equals 5.3148, and so on. So it looks like one girl chatted to me correctly, and yeah, I'm not sure, like chatting to me is optional during the class, although as some of you do, that would be good for us to know like the progress of you girls. And also some of you may also like do those problems yourself when I give you the time during the class, and that's fine too. Okay, we're now going to look at another arithmetic exercise with repeating decimals. This time it involves subtraction. I'll first give you girls a minute to think about it. All right. I'll teach it now. What you could do similarly to the first one is to break numbers down. But this time, for this part, instead of doing 1 plus something, you'll rewrite this. It'll be more beneficial to write this as 2 minus something. You see what that something repeated is. We'll see what's, if we write this as 1 plus 1 minus something, right? And just this part equals 0.307. And we're given actually 1 equals 0.999 repeated, because it equals 9 over 9, which equals this. So theoretically, they're equal. That's also the concept of going infinity, which actually is a hard thing to wrap your mind around. It's very like beautiful, intriguing math concept. Then we'll have, this is 0.9 something unknown. Which then equals 0.9 minus 0.307. I guess I'm going off the page. Then you go forward. You could write 0.9 with a dash on top as with 3 digits with 9 on top too. That means the same thing because 9 is always repeating. And then what you do is just to break them down, since these are all now consisting of like 3 repetitions, we'll just do subtraction like they're integers. Here you get 692, which means that equals 692 and then repeating forever. Now let's go back here. This equals 1 plus 1 minus 0.692 repeated equals 2 minus 0.692 repeated. And you get this. And rearranging numbers, we're left with 3 minus 1, so on. We're left with and then we tackle the whole number part and the fractional part separately. With this part, you'll add by normal whole number addition. I know 7, so plus 0.9 to 7. And here you don't have to group anything like a thousands place, although you did for the tens to hundreds. Oh, it's just 907 repeated equals 1.907. Okay, anyone have any like questions or concerns?
Can you just like tell me the overall how to do it, because I am a bit confused.
Oh, for the question. So what you first break those two numbers up into the whole number part and fractional part. For this one, it becomes 3 plus 0.215 repeated. And for this one, you actually should write for this problem as 2 minus something. 2 minus 0 point something equals 0.1307. Are you following? Are you following me? Girls, do you think, like, are you following me? Or is this like too like easy or hard?
I can follow you.
Okay. Oh, it looks like some of you say it's pretty hard. Yeah, I guess I could either go a bit slower, maybe. You don't have to cover everything today. And let's actually just jump to another concept, to this problem. And before we go back, if we have time, to the arithmetic part. Okay, write the decimal equivalent of 3/11. I'll let you girls try your hand at that.
Wait, which one?
Oh, sorry. Here. Write the decimal equivalent of 3/11.
I don't know the repeated sign, so can I just write a dot, dot, dot behind it?
Yeah, sure. Even I'm not sure how to like input repeated signs into like chat or docs. Okay, looks like we got one correct answer in the chat. So do you girls want more time? Or do you want me to explain now? I guess I'll explain now. So what you do, there's two approaches. One is long division, which I believe that most of you attempted, though I may be presumptuous. By the way, I want to see, just raise your hand, like just on the screen or on Zoom, if you use the long division method. Well, yeah, the long division method basically is like this. You just find the pattern here. Since it has 3/0 again, you see it's going to repeat. Equals 0.27 with a line on top. And another method is to notice that 11 times 9 is equal to 99. Then you can convert the denominator timesing 9 on the top and bottom. We have 27/99. And as we saw with rule 2, that equals 0.27 repeated. I'll now let two girls then try your hand at the next problem. Okay, for this question, oops, I forgot the line. You'll convert them into fractional form, which is 1/9 plus 1/99 plus, this is complicated, but we touched briefly. What?
So would it be 0.12 then 3 repeated?
Yeah, that actually is the answer. And I'll breeze through it because this part is 1/999. You don't have to know this, but you could memorize this in case. But more importantly, it's to understand how it is, and you'll discover more, and you could understand it later in your math pursuit. Then you'll write them with a common denominator for each fraction. This is times 1,111. This 99 times 101 equals 9999. Equaling, as one of you gals said, that equals by an advanced extension of the two rules, this. Like he said, you don't have to know these and be fluent with them now, but just to introduce you to them and the mathematical thinking process of recognizing patterns in the rules. Okay. Next question. Express 1.4, 1.12, and so on as a common fraction. Okay. I think that some of you may have mulled over this
Wait,
one.
can you wait a second? Yeah, you can explain now.
Sure. You could now this time also break the fraction down, but this time instead of breaking it by the whole number point, it'll be better for solving the problem to break it at 1.4 from the non-repeating parts and repeating part. here. And then you write them as fractions. We'll first tackle this part because we don't know what the denominator should be for this to make it integrate with this number, meaning they have to have like the same denominator to express the whole thing as common fraction. For this part, we could write it as 10 times 0.12, which equals 10 times 12 over 99. You can simplify 12 over 99 to 4 over 33, which equals 40 over 33. Now try converting 1.4 into fractional form. 14 over 10, which equals 7 over 5. Our goal is to express this in one fraction. Well, the least common factor of 5 and 33 is 5 times 33, because 5 and 33 don't have any common prime factors. That's 165, which should be the denominator. Then the rest is just calculation. We'll go here. Oopsies. Okay. Now, I guess we're actually almost out of time. We didn't have to get to the Kahoot today. That's okay. Well, let's see. Girls, if you girls want to do the Kahoots now, maybe we could start it, or to keep on going, just tell me, direct message me, and let's see. Okay, do you girls want to do Kahoot? Or do we have got one vote for Kahoot so far? I think we could go with the Kahoot at least the first few questions to ramp up some fun. So I'll show you. I think I'm not sharing my screen yet.
What is the code?
The code is on screen. Yeah, sorry, I zoomed in. Now can you see the code?
Yeah. Thank you.
Olivia, I projected the code on screen. It's the game pin on top. Okay. Do you girls want to join still? Or do we want to start with 5 people? So do you guys still want to join? Or I guess I'll start first and you girls could join with the pin if you want later. Okay, I guess let's just start now. And by the way, if you girls want to leave, you could leave if you have something else, and the recording will be accessible later. Okay, it seems like most of you got correct who answered. It's basically for this number, it's 3, and then you take care of the decimal part, 0.0101, and so on. You know, I ruled 2 that equals 1/99. Therefore, the answer is the triangle. Okay, yeah, this is fairly easy. You just could test each number out. You will find that 0.5955 is less than 0.599, which is less than 0.6. So that can work in the circle. 0.6001 is greater than 0.600. So it's greater than both numbers. Only 0.5994 works. All right, we'll do one more question and then end the class. Yeah, looks like only one of you got it. What you do is long division. It's like, yeah, pretty complicated with calculations. I'll leave you girls if you want to try it on your own at home, probably. And good job, everyone. This week for the homework, it's posted under questions, which will be an assignment soon. And also the Cami doc is accessible on my post from yesterday. There's like some things later, like some problems. They're optional if you want to explore them or not. They're like pretty like intriguing but more complex math skills and learning. So if you're like interested, feel free, but it's not required for success in this class. And thank you all for attending, although I made some mishaps today. Yeah, thank you all.